Hey everybody, this is video 12. We're on our limits and derivatives unit, and we're going to be taking a look at how we can use our second derivative to learn about our function. And we're going to be talking about points of inflection and concavity. So before I get started, you might want to write this down. At the bottom of the paper there should be room just to write a definition of what the points of inflection are. A point of inflection is where the graph is going to turn between concave down and concave up, or vice versa. So I'm going to draw a small picture here to show you what I'm speaking of here. Concave down is something where it's like it wouldn't hold water. Okay, this is not going to hold water if I were to fill this picture up. This would be concave down. And then if I have something that does hold it, like a cup would be concave up. So a cup is concave up, where concave down, I guess I've had students in the past say concave down is a frown, if that will help you remember which one is which. So the point of inflection is the point in which the graph where it turns from concave down to concave up, or vice versa. That's just our definitions. So let's go ahead and do this. We're going to be using a second derivative test. So we have to first find the second derivative. So I've got y prime to equal 3x squared and y double prime to equal 6x. So that is my second derivative. Now just as we've done with the first derivative, we're going to be setting this equal to 0. So 6x equals 0 gives me x equals 0. To find any ordered pair, we're going to always go back to the original. So if I substitute a 0 in, I get the ordered pair 0, 0. What we've just found is our point of inflection, which I'm going to abbreviate POI, the point of inflection. Next, I'm going to find out where my intervals of concavity are. So exactly what we did with the first derivative is we're going to use a second derivative test. I'm going to put that x value that I've got on my number line, okay, which happens to be 0, and then I'm going to test on either side. So I'm going to choose some testing points, a -1 and a +1. These are always going to be tested in the first derivative, or the second derivative, because it is a second derivative test. When I substitute a -1 into my second derivative, I get a negative value. Okay, when I substitute a +1, I get a positive value. What this tells me is that on this side of 0, on this side of actually 0, 0, it's concave down. And then when it gets to 0, 0, it then turns concave up. Now this is just a rough sketch, but this tells me everything I need to know about the concavity. So 0, 0 is the point of inflection, and then I'm going to write my concave down interval and my concave up interval. So it's concave down everywhere from -infinity until 0. And then it turns concave up from 0 to +infinity. So it's the second derivative test that gives us our point of inflection and concavity. Let's go ahead and try this one. So I'm going to start by finding my second derivative. My first derivative is 3x squared plus 6x plus 5. My second derivative is 6x plus 6. I'm going to set the second derivative equal to 0 so I can find the x value, and I come up with x equals -1. When I substitute the -1 back into the original equation, I actually get a -1 as a result as well. So putting in the -1 back into the original gives me -1. That's the ordered pair which I have my point of inflection. So that's the first part. The second part is using the test to determine the intervals of concavity. It's a second derivative test, so I'm going to substitute in my test values in the second derivative. So I'm going to grab, let's see, -2, and maybe we'll test a 0. Okay, so if I test a -2 in the first derivative, or the second derivative, sorry, and I put a -2 in there, I get a negative value. And when I put in a 0 into the second derivative, I get a positive value, which means that on this side of -1 it's concave down, and on that side of -1 it's concave up. So I get, again, a very similar picture. So to write my intervals of concavity, I'm concave down from -infinity to -1, and concave up from -1 to +infinity. So it's very much like the intervals of increase and decrease, except I'm talking about now the concavity. let's go ahead and take a look at the next one. So I'm going to do number 3 with you, and here we're looking for all of our critical points. And what that means is, oh gosh, sorry. And what that means is I'm actually going to be looking for my max and my mins. So I've got my max and mins. I've got my intervals of increase and decrease. I'm going to find my points of inflection and my intervals of concavity. So I have quite a bit to do. I'm going to be changing colors so you can see sort of where everything goes. I'm going to be starting with my first derivative and the first derivative test. So my first derivative here is going to be 12x squared plus 6x. To find my max and minimum values, I always want to set this equal to 0. So I'm going to take 12x squared plus 6x equal to 0. I'm going to factor out a 6x and get 2x plus 1 equals 0. So x equals 0 and x equals negative 1/2. Now those are my x values, 0 and 1/2. Those are the negative 1/2. My x values of my maximum and minimums. They're also the values that are going to end up on my number line for my first derivative test. And as you can see, I've left you plenty of room for the problems you're going to be trying because they do take a little bit of room because we're doing quite a lot of things. So I'm testing these two x values here as my first derivative test, and I'm looking here for increasing and decreasing. Knowing whether it's increasing or decreasing will help me determine which one's a maximum and which one's a minimum. Okay, so I'm going to test here maybe a -1, a -1/4, and a +1. When I test these values back into the first derivative, so I'm testing these here, testing them in my first derivative, putting in a -1 will give me a positive value. Very carefully enter in -1/4, which you can also use -0.25. When I do that, I end up with a negative value. And then lastly, when I put in a +1, I end up with a positive value. So right now, I know that this picture of my original function goes increase, decrease, increase, which means that it increased up to this -1/2 comma something and decreased down to 0 comma something. So let's go ahead and write our intervals of increase and decrease, and we're going to go back in and fill those values of my max and min. So intervals of increase and decrease. It's increasing from -∞ to -1/2. It's also increasing after 0, so from 0 to +∞. We know it's decreasing right there in the middle, so from -1/2 to 0, it's decreasing, which makes this increase here lead to this being my maximum and this one being my minimum. Let's find the y values on those as well. When I substitute in 0 into the original function, I get 0, 6. When I substitute in -1/2 into the original function, carefully try that, I get 25/4 when I turn it back into a fraction. Okay, so now we're moving on to the second derivative test. So I got to find the second derivative. So my second derivative is going to be 24x plus 6. I'm going to set the second derivative equal to 0, and I'm going to get x to equal -1/4, which means my point of inflection is at -1/4 comma whatever that is when I substitute it back into the original function. So let's do that first. Put in the -1/4. You may also use -0.25 back into your original equation. You should get 49/8. You can just hit math, enter to get the fraction. Okay, well now my second derivative test. So I go to the number line again, and I'm testing on either side of -1/4. I wouldn't make it too complicated. Just choose two values that are far enough away from -1/4 that you don't have to think too hard when you substitute them in. Again, I'm substituting these values into the second derivative, not back into the original. The only thing that ever goes back into the original is going to be if you want to find an ordered pair. So if I go on the left side of this and I look at -1 and I substitute that back in over here, I get a negative. And when I substitute in 0, I get a positive. Okay, again, you can test different values. If you wanted to test positive 1, you'd still get a positive value. If you wanted to test positive 2, it's still a positive value. All right. This means that on the one side of negative 1/4, it's concave down, and on the other, the right side, it's concave up. So I have my intervals of concavity. My intervals of concave down, which you can abbreviate the same way I have, or you can write it out, is from negative infinity to negative 1/4. And from concave up, you're going to see it goes from negative 1/4 to positive infinity. So not only have I found my maximum and my minimum values, intervals of increase and decrease, we were able to use the second derivative to find more about this function. Remember, everything that we're finding here is actually describing the original function. It's talking about 4x cubed plus 3x squared plus 6. These individual pieces help us with describing the original equation. Okay, so I've left for you to try the 2 on the back page. Very carefully look at those, and as you go to start to factor things, remember there's multiple ways to factor, and we'll take a look at those together when we're in class, but definitely give them a try and at least find as much information as you can.